All right, these are a challenge problem and a real-world connection problem in our factoring unit, specifically with regard to factoring ax squared plus bx plus c. So where the coefficient with the x squared value is not 1, so it makes it a harder problem. I encourage you to pause this video, give these a try on your own, and then come back and check in and see how you did. All right, so this one on the left, yikes, we have a p, a q, and an x in there, along with some negative signs. It looks just really tough. So, okay, first we can pull out an x. X looks like our GCF. So I'm going to just pull an x out front, and we have a 15p squared minus pq minus 2q squared. What I am guessing here is we are going to end up with something like this. Something with a p plus q and a p minus q. And there'll be some numbers in there as well, which we don't know what they are yet. Because this piece turns into a p squared, gives us our p squared, gives us our minus q squared, and depending what the numbers are, we should be getting a minus pq in there as well. And I'm thinking about how best to approach this. What I actually want to do, I think, is pretend the p's and q's aren't there. Let's do a sample problem with, or a similar problem with just x's. And so let's just try this and see if it makes some progress. So I'm going to turn this, just for now, just temporarily, into a 15x squared minus an x minus a 2. Okay? Just to get the same pattern of numbers, I'm forgetting about the p's and q's for now. I'm going to do the AC method. So AC is negative 30. So I'm going to split that up into, looks like negative 6 and 5. So 15x squared minus 6x plus 5x minus 2. Okay, so let's go ahead and try to factor each piece, pulling out the GCF from each piece separately. So this, we can pull out a 3x, and we're left with 5x minus 2. And this, we can't pull out anything, so it's a 1 and a 5x minus 2. So it looks like this factors into a 3x plus 1 and a 5x minus 2. Okay, let me be clear. This factors into that. Okay, we haven't solved the full problem yet. So let's try some stuff here. I'm going to keep all that. And let's bring this up. And what I'm going to try is to just get rid of my x's and throw in a p. Let me write it a little bit larger. What would it look like if I just did this? So now that I know the numbers, I can just throw in p's and q's. So let's FOIL that out to c. So just to be clear, we are trying to see if this piece is equal to that piece. Okay? And let's do it. So the first two terms, we get 15p squared. The outer two terms are minus 6pq. The inner two terms are plus 5pq. And the last two terms are minus 2q squared. And that, I wrote an x. I should have written a p. Does that check out? These two do combine together to give what we want. Okay, so it looks like we got it. So our final answer is going to have that x, that GCF out front, and then a 3p plus a q, and then a 5p minus 2q. Wow, that was a challenging one. There are probably more efficient ways of going through that one. But I thought that was a little bit clever, just to get rid of the p's and q's for a moment and pretend it was just a normal x squared trinomial and try to figure out what the numbers are. But it looks like we got it. All right, the next one. A rectangular window has an area of 6x squared minus 23x plus 20. So let's draw a picture here. and its height is 3x minus 4. Determine its width. Okay, so this isn't so bad once we see what we're doing. We are really just looking to factor that area into two terms, and we already know one of the terms. So we are already in pretty good shape. So let's look at how this 3x compares to the 6x squared. Looks like this needs to be a 2x. So 3x times 2x gives us a 6x squared. Let's next look at how the minus 4 compares with the plus 20. So it looks like this needs to be a minus 5 right there to multiply and get a positive 20. And now let's FOIL things out to check. 3x squared is the first two terms, minus 15x. Inners are 8x. Lasts are plus 20. Yep, looks like it checks out. Okay, so that means our final answer is this right here, 2x minus 5, which I'll write up on top of my rectangle. So that would be our final answer right there. Nice. That's a good place to stop right there.